Welcome to the Math Tutor Training module of the Branching Out Ministries Tutor Training. My name is Lisa Bieneman, and I'm going to walk you through some things we'd like you to think about as you're tutoring students in math. First, regardless of your own personal attitudes about the subject, it is so very important that you project positivity about math. Math is all around us, and we need to teach our youth to embrace it. Math is used daily by some people, but all of us use things that were created from math, like mobile devices, computers, software, architect, art, money, engineering, and even sports. Math is completely based in logic, and we all need to learn how to think logically. So we ask that you help your students recognize the value in learning math. Math literally teaches us to think logically. Because logic is the foundation for all math, it is supposed to be logical. As students progress to middle school and high school level math, they sometimes feel like math is just a bunch of processes that are independent of each other and completely unrelated. And this is absolutely wrong. It's all connected. At the very least, doing math is like constructing a building. You have to have a strong foundation because each floor gets built on top of the one below it. If a math concept doesn't make sense to a student, try explaining it in another way, or ask another tutor for help. Sometimes we can use manipulatives to show concepts in a more concrete way. You can find lots of manipulatives that you can use right in our tutoring space. These are things like blocks, colored chips, shapes, fraction tiles or fraction circles, spinners, clocks, coins, even paper and scissors. Anything that can be used to physically model a concept. Next, we'd like you to encourage students in math. Math anxiety is very real, but kids aren't born with it. It develops over time. In fact, students sometimes learn to have negative feelings about math because of the negative attitudes they hear or sense from adults. This makes it so important to help students experience success in math. It also helps if we avoid using phrases like, "Oh, this problem is easy," because this can be intimidating to a student who doesn't think it's easy at all. Or it can make them feel like they're not smart enough to do it because they don't understand it yet. If a student gets a problem wrong, just point out the things they did right while correcting their errors. These are great learning opportunities. Encourage students to ask questions and be sure they understand that there are no stupid questions. You can model this for them by asking questions that will help guide them to the correct solution. Try asking things like, does this solution make sense? What exactly is the problem asking for? What techniques do you know that could help you solve this problem? We encourage you to use questions to find out what the student knows and what they still need to learn, and then start at that student's level. Although students do need to learn the correct math vocabulary, you might just use simple words at first. For example, if a student doesn't already know what a numerator is, start by calling it the top of the fraction and use that along with the word numerator until you're sure that the student knows what numerator actually means. You can also try to use a student's interests to help them connect with a topic. For example, a student who's interested in baseball might have an easier time understanding the relationship between decimals and percents in the context of a baseball player's batting averages or other statistics. As I said earlier, all math is connected and it's everywhere in our world. So if possible, help students see this. For example, if you're working on algebraic rational expressions, point out that the rules for these are the same as the rules for plain old numerical fractions, and that something like polynomial long division actually mimics numerical long division. You may be able to point out a connection between what they're learning in math right now with future topics, or even that topic in other subjects. For example, students learn how to use scientific notation in math class, and then they use it a lot in science class. And you may actually be able to tell students how the math they're learning can be used outside a classroom. For example, if they or someone in their family are in the market for new carpeting, it helps to be able to calculate the number of square feet or square yards in their house. This is straight out of geometry. It's also important to note that math is not a spectator sport. Students will try to make it one, but don't let them. Students learn best when they are engaged in the process, and this is especially true in math. They shouldn't be just watching you do math. They should be doing it themselves as you encourage them. If they get to a point where they struggle, you can try to get them through that rough spot by asking leading questions until they figure it out. Or you can give them a mini lesson and remind them of what they learned in the past, and that may help them to finally solve it. If possible, help students understand why we do what we do in math. This would actually be a great time to use manipulatives to model math concepts, especially at the elementary level, such as the meaning of fractions and the meaning of equivalent fractions. I actually have a link to a YouTube video here that you could watch as you go through this PowerPoint, as well as why fraction must have the same denominator, why fractions have to have the same denominator to be able to add or subtract them. You can use manipulatives when you're teaching how to read an analog clock to tell time, or how to count money. You can also just use a piece of paper and scissors to model geometric formulas. For example, if you take a rectangular piece of paper and divide it into equal-sized perfect squares, just draw them out, you can explain that the area is the number of perfect squares that fit inside of that rectangle. And then you can use that to justify the formula that area equals, you can think of it as either base times height or length times width. And then you can take it a step further. You can cut that rectangle along a diagonal, creating two triangles, to justify that the formula for the area of a triangle is actually half of the area of that rectangle, so half base times height. Using basic definitions to show students why algebraic rules can really help a student, why algebraic rules work, can really help a student when they can't remember when to use which rule. Students often mix up, for example, rules of exponents. They can't seem to remember sometimes when to add them, when to subtract those exponents, and when to multiply those exponents. But if you show them how to take it down to the basic definition of what an exponent means, they can do that in a pinch when they can't remember the rule, which is essentially a shortcut. So in this example, if a student doesn't remember that they should be adding the exponents when multiplying x to the third times x to the fourth, they should write out what x to the third means and what x to the fourth means. So x times x times x, and then x times x times x times x. And then they can actually see that they now have 7 vectors of x. And you'd get 7 by adding the 3 and the 4 up in the exponents. And so when you're multiplying and the bases are the same, we add our exponents. That's just an example. As you know, we should never do the work for the students or tell them the answers. Instead, ask questions to determine what the student knows and what they don't know. Make sure you go at the student's pace, making sure that they understand as you go. You can watch students work out a problem to determine at what point they might need help. Ask students to talk their way through a problem so that you can hear their thought process. Help them learn from their mistakes in a positive way. And when you realize they're missing some key piece of knowledge or some skill, teach those things first so a student can be successful. And here are a few last ideas that may help you. Use examples to teach. You can make them up, or you can use books, or even online sources for more. Ask to see the student's notes and/or the teacher's slides or notes. There are usually multiple ways to look at or do every kind of math problem, frankly. But for the sake of consistency and not confusing the student, try and stick to the methods their teacher uses in class. You can draw diagrams, make timelines, or draw concept maps to help students understand the concepts and how they're related. Visual aids can be very helpful. Use incomplete outlines when you fill in the major concepts and some of the problem-solving steps, and then the student must fill in the rest. Give the students several problems that have something in common but are also different in a way, and ask them how they would solve each. You can also give informal quizzes to check for understanding. This is just making up a couple of problems or more to see if they truly understand. Or again, you can find them in books or on online sources as well. Well, thank you again for the time, the care, experience, and effort that you volunteered to give to these youth. This program is lucky to have you. Thank you for watching.